So here we have an electricity. So it says in the second diagram below, it shows a battery with the EMF of 12 volts and an internal resistance of 0.5 ohms connected to the resistors. The light bulb and the switch and the ammeter, and also connecting wires. So the first thing on that I'm not going to include is Ohm law. I think the Ohm law is something that you should know by heart, because it's just something that is there on your guideline, or a teacher should be specific on how you should define it. So now we're just going to do 8.2. So it says calculate the external resistance of the circuit. So let's just discuss the idea of external resistance. What is an external resistance? If you did not understand what is an external resistance. So, okay, let's make it simple with this diagram, okay? So, you see here, in this circuit, we have all these resistors here that's in the circuit. If you combine all of them, they give you a total resistance. We do not include your internal resistance. That's why it says external, because the internal one is not included. So it is an external resistance, or it is a R total, or the total resistance, by the way. But to make it more sensible, they said R external, because this internal is not included, so only the external circuit or the external parts of the resistors are being included. If you want to find R external, you can combine the R parallel plus the R series. You can get the R total. But if we're dealing with this case whereby with only this, maybe say this is a battery. If you're dealing with this case, you see you only have series resistors. So when they calculate you R external, you just need to combine 5 plus, let's say it's 4. It's 5 plus 4. Then you get 9. You see? You're down. This is your total resistance, or this is your R external. You can call it whatever you want. Well, if you now have parallel resistor, maybe this is 10. See, now you need to combine this 10 plus 4 because they're in series. And then now what you need to do is to add issue with them. Okay, you combine 5 before you get 9, then you introduce parallel, because these two are parallel to this 10. Then we're gonna say 1 over 10 plus 1 over 9. Then you're gonna get your new answer. Hopefully, this really sets about external resistance, in case you didn't understand what I mean when I'm talking about external resistance. So to answer this question, okay, you see we have all this circuit here. So my approach is to break it, to start by combining these two using the parallel formula, and then take it into consideration that if you combine these two, they become one. So you have, I don't know, if you combine these, maybe they say you get 5 ohms. Now you're gonna say 5 plus 10, you're gonna get 15. So the parallel resistance is equal to 15. So if now we have to combine these two using the parallel formula, because you can see that this is on the other bridge and this is the other side of the bridge. So you need to combine these two using the parallel resistance formula. So hopefully, and everything is clear. Okay, let's start by combining R1 and R2. quiz 1 over RP is equal to 1 over 10 plus 1 over 10. If you combine 1 over 10 plus 1 over 10, this should give you the occurs 1 over 5. Then you flip. If you flip this will give you R parallel with equal to 5. So the answer is 5. So you will know that this, when you combine this, it gives you 5. So it gives you 5 ohms. Now you have to deal with this 5 and a 10 to have only one resistor in this bridge. So you're gonna just add, is your axis, it's gonna be 5 plus 10, and this is simply 15 ohms. Now you have 15 in this side. This whole side is, when you add the resistance, it gives you 15. Now you have to add this 2 using the parallel formula. So 1 over RP is equal to 1 over 15 plus 1 over 15. Then punch your calculator. 1 over 15 plus 1 over 15 should get 15 over 2. Oh, it's 2 over 15. 2 over 15. When you flip this, and then your other parallel will be 7.5 ohms. So you need to add using the correct formula. Don't add just numbers, just know which formula to use. So we have 7.5 ohms. And the second question, calculate the reading on the ammeter. Okay, see here is our ammeter. You see it is on the main circuit, so it's gonna be our total current flowing through the circuit. So you know also we have been given the EMF, so we just need to use the formula for EMF. But EMF is equal to I into R external plus an R. So you do have an EMF. We're looking for a current. We can calculate. We calculated already the R external. So here divide the final answer for the R external. So we also been given the R internal with the internal resistance. So we just need to plug everything. So the EMF is equal to 12. Our current is what we're looking for, and our external is 7.5, and then our internal is 0.5. So when you add everything, it should give you 8. Then it will be 8. Then divide with an 8. Then divide with an 8. Your current would be 1.5 amps. By the way, 1.5 amps. So hopefully it was helpful to you. So yeah, the main trick was to be able to add the right resistors using the right formula or the correct formula. Okay, let me try to explain this before I close the video. So you see here we have this part. Okay, you will only have this part, so don't go to the underneath part, this one. Okay, start here. This one is more complicated. They say you deal with it, you combine it using the formula. You know which formula to use when you combine it. When we have two resistors in parallel, you know the formula to use is the parallel resistance. So when you solve, it gave us what? 5. So you imagine now this as a single resistor of 5 ohms, a new single resistor of 5 ohms. So you can cancel this one and have 5 ohms instead. So I'm just gonna add. So 5 ohms is connected with this other wire. So we'll cancel this. You see now. Now we have 5 ohms and 10 ohms. They're in series here because they are in a straight line. So you add them When you add them, you get what? 15. Now you have 15, the total overall here. When you add everything, it gives you 15. Now we draw your new, let me draw here. Your new resistor will be 15 ohm on the upper bridge. Okay, let me